Okay, thank you, Wai Min. I'm the speaker for today. My name is Kai Bin. Just a brief introduction about myself. I work in Securiton, Malaysia, and I support business partners technically in the Asia region and also other countries internationally. Today's topic of webinar is fire detection in electric vehicle. What are the technologies available? This is the agenda for today. We'll go through the introduction, see what causes lithium-ion battery fires, use lithium-ion battery fire detection, how to put out a lithium-ion battery fire, and the standards and guidelines available. And in the end, we'll wrap things up. So electric vehicles is gaining popularity, as you can see in the graph at your right. The sales of EV skyrocket after the COVID situation in 2021. And I believe sales of EV vehicles, electric vehicles will continue to grow year by year. So why is this happening? Because countries are taking initiative to reduce CO2 emission, and the governments are giving favorable subsidies and policies to encourage people to buy EV cars. And with the stabling of the EV technology, the prices will decline. And the marketing done by the EV manufacturers is quite good. It's a new technology and people want to buy it because they want to have a new toy. And its futuristic looking designs make the sales of EV going up year by year. So you can see in the picture at the right, this is Mercedes-Benz EV that has caught fire in JB Jalan Skudai. So in the news, we can often see fire of EVs highlighted, but there are no evidence saying that EV fire risk is higher than conventional cars, petrol or diesel cars. So, but EV cars is quite dangerous compared to a conventional car because the fire will shoot out and it will destroy the car at a very fast pace. So this fire has destroyed about 90% of the car, 5% of the showroom building structure, and as well as 20% of the EV charging bay. So as I mentioned just now, EV fire is dangerous because the temperature can go insanely high up to 1000 degrees Celsius. Whether the normal building structure can withstand these kinds of temperature, we have no idea that because there's no research being done about this. Yeah. So EV fires develop much more faster than the conventional cars due to a chemical reaction inside of the battery called thermal runaway. So EV fires cannot be extinguished, but only be cooled down. Both of these reasons make it a higher risk to spread to the nearby cars. So for a normal petrol or diesel car, only 200 gallons of water is needed to put out the car fire. Whereas for an EV, 10 times more water is needed. to put out the EV car. This is a car park that caught fire because of EV, and it spreads very fast, as you can see. The whole car park, many cars were destroyed. So EV fire also create tons different types of pollutants, including carbon monoxide and hydrogen cyanide, high concentrations of heavy metals, lithium, and whether this water that is used to put out the fire, is it treated before going to the drain? We do not know. So these are the standards in Malaysia, guidelines to install the electric vehicle charging bay. So they allow charging with AC current less than 22 kilowatt to be installed at any levels in the building. However, for DC current with power more than 22 kilowatt, only certain levels are allowed to have this EVCB installed, which is the electric vehicle charging bay. So can the structure of the building withstand an EV fire? There is no research being done on this. So it's quite a higher risk to install EV in confined spaces. So it's interesting to ask ourselves these questions. Can we detect an EV fire at an early stage and ideally prevent it? After an EV fire is happening, how can it be localized to support the firefighters to pinpoint the location of the fire or to trigger the extinguishing system to the right location? How can EV fire be extinguished, and what are the consequences of EV fire? So we'll look into the fuel source of a EV car, which is the lithium-ion battery. There are three main reasons from FM. This is from FM, the highlighted that causes fire of the EV or of the lithium-ion battery, which is the physical damage, any penetration or compression or damage to the one of the battery cells will cause a fire to the cell. Overheating due to external heat, which is thermal abuse, will also cause a fire to the the lithium-ion battery and to the other cells. Overheating due to overcharging, which is electrical abuse or electric short circuit. This will also cause a fire. And the other one is some manufacturing defects or malfunction of the battery might also cause a fire. So for your information, in a battery car, around 5,000 to 9,000 cylindrical cells are needed in an EV car as a fuel source. So a lithium-ion battery fire develops in 3 steps. One, the thermal runaway. Before thermal runaway, gas and smoke are emitted in this stage. And when the thermal runaway happens, the temperature goes more than the cooling system of the battery, and this will cause a fire to the battery. So if the fire is caused by overheating, it might take several minutes before the thermal runaway happens. But if it's caused by a mechanical damage, the fire is almost immediate. So what are the fire detection that can be used to detect this lithium-ion battery fire? One of the method is gas detection. The other one is with smoke detection, but this smoke detection must be a highly sensitive smoke detector, such as the aspirating smoke detector. Thermal detection can be used after the fire has happened by using addressable linear type heat detectors or thermal cameras. So before the thermal runaway happens, about 5 minutes duration, these gases are emitted by the battery cells, and carbon monoxide is one of the most gas emitted during this stage. Other gases include carbon dioxide, hydrogen, ethane, and benzene. So there are some manufacturers saying that lithium-ion battery fire can be detected several minutes before the thermal runaway. In case of overheating by charging, the thermal runaway can be stopped by stopping the charging process. So almost at the same time during the gas emission stage, before the thermal runaway, so you can see here, smoke is also emitted. This is a white paper by Siemens. And some manufacturers say that we can detect the smoke several minutes before a thermal runaway. So in this case, we can stop the thermal runaway from happening by stopping the charging process. So after a thermal runaway has happened, large amounts of smoke and heat are dissipated. So smoke detection will not allow a localization because the smoke is spreading throughout the building. Linear heat detectors, addressable type, can help to pinpoint the location of the fire to help the firefighters or to trigger the extinguishing system. Firefighters will only go into the building to put out the fire if they know where the fire is located. The other way to detect or localize a fire is using thermal imaging cameras. Other detection methods are not so suitable in this case because normal point type detectors are smoke type is not so sensitive, and heat point detectors are not suitable to be installed in parking or tunnels. And video fire detection can only detect smoke at the early stage, but after the thermal runaway happens, you can see there is a large amount of smoke and it cannot pinpoint the location of the fire. So this will happen if the building has no smoke management system or smoke spill fan in the parking area. So these are the challenges in fire detection system. Because of the protection of the battery compartment, gas and smoke will only be released at a very late stage. So it's too late for the detection system to detect the fire. And if the smoke concentration is too high, there is a risk of vapor cloud explosion. So to wrap things up, a lithium-ion battery caused by overheating can be stopped if gas and smoke detection is able to detect before the thermal runaway happens. But if the fire is caused by physical damage, the fire will happen much more faster and early detection is hardly possible. So let's look at how we can extinguish a fire. The commonly used methods are foam injection, high pressure water, mist, sprinklers, and gas separation. system. So for foam injection, it can cool down the fire. High pressure water means it can also cool down and absorb the gas. Sprinklers can cool down the fire but has less gas absorption. And gas suppression system can put out the fire, but it has a reduced function in cooling down the fire. So this is our Malaysia guidelines on installing electric vehicle charging bay. This is by BOMBA, our fire authority in Malaysia. So it's important to have an isolation switch located nearby the EV charging bay. As mentioned just now, the thermal runaway can be stopped if the fire is detected before the thermal runaway by stopping the charging of the battery. So this is one of the guidelines. If sprinklers are not installed, heat detection and multi-sensor detecting type is needed. And also, they recommend to have vehicle fire blanket nearby the charging bay. So early detection of lithium-ion battery fires is possible by gas and smoke detection. However, this is only if the detector has access to the emission of the cell. Gas detectors and highly sensitive ASD are most suitable for this purpose. Before thermal runaway happens, the thermal runaway can be stopped by isolating or cutting off the power source to the cell. After the thermal runaway happens, addressable type linear heat detectors or thermal imaging cameras are suitable to localize the burning vehicle. So this is a possible solution to detect a fire for EV. However, there are some challenges because ASD might detect the smoke produced by conventional vehicles. So these are the challenges we need to overcome. So I pass this to you, Wai Min.
Okay, thank you so much, Kevin, for the presentation. Yeah, just to quickly add on to what Kevin was saying about the possible challenge of detecting fire in today's age and time, where we're talking about like for example, a basement parking structure facility. So that's why we have both electric vehicle parked together with conventional, combustible engines, like ICEV they call it. So because of the presence of the conventional vehicles, the smoke coming out from the exhaust. So in this time and age, where EV has not gone mainstream yet, so we see, parkings of, the modern vehicles, so-called, and then with the conventional vehicles together. So ASD will probably fail in this challenge. But who knows? Maybe in the future, where EV has gone mainstream, EV has taken over the market share in terms of the type of vehicles on the road. So maybe in the future there'll be like a dedicated parking structure, parking facility just for EV vehicles, and there's no presence of conventional vehicles. Then perhaps ASD can be used to tackle this issue. Referring to what Kevin was saying. And then of course linear heat detectors to detect, of course, when after fire has occurred, the first level has failed, so to speak, and then you have LHD linear heat detectors to come in to detect and to detect the localization of the fire. Yeah. So yeah, thank you so much, Kevin, for your presentation today. Just want to check if you have any questions. The audience, the participants, do you have any questions for us? We would be glad to address them now, because we are actually way earlier than our estimated duration. Yeah, we have a question from Athena. What is short for LHD? Do you mean the full name for LHD? If that's what you mean, it stands for linear heat detectors. Maybe Kai Bin can further expand on that.
Linear heat detector is you can see. Do you see the mouse cursor? Yeah, I share the pointer. So these are heat sensors, temperature sensors embedded inside the cable, and this will pinpoint the fire location in case there is any fire happening. True rate of rise and also maximum temperature alarm. And our linear heat detector has an advantage because it can also detect heat through radiation. It's sensitive to radiation heat. And this sensor is protected by the cable, and it can work in very harsh environment. In case a fire happens and the cable is not damaged, the heat detector, linear heat detector, can be still used. So another term for this linear heat detector is a resettable type linear heat detector. So this type of detector can be still used even after a fire happens.
We have
I hope I answered your question.
okay. So another comment, approvals. I think you're talking about approvals. So for ASD, I mean, focusing on these two solutions in the slide. So ASD, we have full-fledged approvals. If you're talking about like UL approvals, FM as well, FM approvals. And of course, locally in Malaysia, we also have bomba approvals for these aspirating smoke detectors. But if you're talking about linear heat detectors for this particular type, let me see.
We have VDS approval.
Yeah, VDS approval only.
Yeah.
For the moment, for the time being. So we may have new development in the future for this LHD in terms of other approvals. So we are still open for questions if you have any. There's a question.
So
yeah.
Yes. If there is any changes of temperature by 0.1 degrees Celsius, our linear heat detector is able to detect any changes up to a resolution of 0.1 degrees Celsius.
Okay. And Athena asks, could you provide catalog for ASD? Definitely, LHD. We can provide that to you after the webinar, for sure. Okay. So I think for now we are not seeing any more questions. So we just the webinar has just reached 30-minute marks. So once again, thank you so much for your time. We further anticipate or expect further engagement from you regarding this topic. Please feel free to contact us. As you can see on the slide now, these are all our contacts, our email addresses. Please feel free to reach out to us of any technical clarification of this particular subject that we wish to clarify in the future. You may not have the question now, but maybe sometime later, if something pops in your mind, please feel free to reach out to us. Just to also add on, like I said earlier, we are present in Kuala Lumpur, in Selangor, Malaysia. So we always welcome you to visit us if you want to understand more about Securiton and the solutions that we offer. We have demonstration unit in the office. We have proper meeting rooms to host you. We can have a session there if you like. Yeah. So if we do not have any further questions, I would like to again thank you so much for your time, for joining us today. Also, just to let you know, also we are planning the second webinar for this year sometime in March. So soon, next month. So please look out for our next email invitation for the upcoming webinar in March. Yeah, so hope to see you again in our next webinar. So with that, I would like to wrap up this webinar. Thank you so much for your time.